everyone, this is Dr. Zach. So today we're still going to find the volume of a figure, but we are going to use a different method. This method's called the shell method, and let's begin. For your lesson preview, you should have been reminded that the area of a shell, or the outside of the soup can, is 2 pi RH. And then, if you think about it, if we were to multiply by the thickness of the paper, that's going to be the volume of the paper. So the formula to find the volume of a cylindrical shell should be the volume is equal to the limit as n goes to infinity, the sum k equals 1 to n, 2 pi r, and this is with respect to x, times h with respect of x, dx. Or volume equals the 2 pi integral from a to b of r of x multiplied by h of x. And then, of course, the thickness of the paper is dx. So from the lesson preview, let's begin finding volume. So we're asked to find the volume of f of x. And f of x is a nice little quadratic equation which has zeros at 0 and at 4. Now, we are bounded by the x-axis, so you can see your region. We're looking for the area to be rotated about the y-axis. Now, as you've been practicing, you know that you're supposed to draw the radius from where you're rotating to the edge. And I hope you see a problem here. That green piece is going through both sides of the curve. That green line is representing the radius. So we need a different method. We're rotating about the y. So for this problem, we are spinning on y, but using the y values might not be in our best interest. I'd really love to use the x values. So the disc and washer method is not going to work very well here because we can't even solve for x. So let's come up with a new method. If we were to think about the radius, once again, is going to be how far across it's going. But I don't want to use x's this time. I want to spin across the y-axis, and I want to use x's, so not y's this time. So how long is that red line that I drew? The radius with respect to x has a length of x. Now, the height is perpendicular to the radius, and it always will be. So the height with respect to x is the function f of x in this problem. So when I find the volume using the ideas from your lesson preview, we have 2 pi integral from a to b, the radius with respect to x times the height with respect to x, but then we want to multiply by that thickness, which is your delta x. So in our problem, this is 2 pi, the integral from, using x values, we're going to go from 0 to 4. The radius is x, and the function is x times x minus 4 dx. So once we integrate that problem, we will have the volume. But this is a different method. This is called the shell method. So the next question, if we were to sketch the graph of x equals y squared, that's your sideways parabola, trapped by x equals 1, and of course y equals 0. So the piece that has all three, I think we're just going to be looking for the top part of the function. Now for this problem, we're going to be rotating about the x-axis. So if I rotate about the x-axis, the question is, can we use the disc and washer method? And the answer is yes, because if I go from where I'm spinning to the outer edge, I'm going to be just fine. And I will use y equals your x to the 1/2 power, and it's going to be just fine. But what if I want to spin on the x-axis but use my y values? So let's try the problem again. Yes, I have an answer the first way, but if I try to do the problem with the shell method, Well, the radius, let's go back to our picture, is going to be coming off of wherever we're spinning. So the radius in this problem goes to some arbitrary point within the center, and the height or the radius is x. The height is perpendicular to the radius, and that height is going to be a right minus left. So if we do the height with respect to y, that's going to be 1 minus y squared. And the radius with respect to y is just going to be y. Now, one more time. The radius is drawn from wherever you're spinning to however tall it is. And I wrote x, but that really should be a y. And the radius with respect to y is y. So our volume, which is 2 pi integral. Now, what are the y values that we're using? We're going from 0 to 1. Height with respect to y, which will be our 1 minus y squared, and the radius with respect to y, which is y. There's your dy. So one more time, this is 2 pi r h, and then the thickness. And that is our shell method, 2 pi r h multiplied by the thickness. So let's talk about the shell method again. When we have a horizontal axis of revolution, we are going to spin x, use y's. When we have a vertical axis of revolution, we're going to spin y, use x. Notice how that's the opposite of the dishwasher method. The area formula we're using is 2 pi rh. And then to find the volume, we're going to multiply it by some sort of delta x or delta y. I'm not sure why I put a t there. So delta t is representing the thickness of the shell. The radius is always perpendicular to the axis of revolution. Now, take a look at the pictures. Make certain they help you find the radius and the height. The idea is we're going to find the volume of each of these shells, which depends on how far away they are from the center of your axis of revolution, and then we're going to add the volume of each one of those shells. So let's take a quick look at our graphs, and the graph we have is going to have a 0 at 0. It also is going to have a 0 at, let's say, the square root of 2, which is about here. You know what? I'm going to make this one 2 and just stretch it out a little bit. All right, here's my graph. We have the x-axis as a boundary, and we're going to integrate from 0 to 1. All right, so x is going from 0 to 1. This is the region I'm looking for. Now we want to spin about, you should have equal signs. We're going to spin about the y-axis. Now, if I spin about the y, think about this. Spin y using x's. The reason I want to use x's is I can't solve this equation for x. Spin y, use x. 2 pi r h is my formula. So I need to know r and h. So we're spinning on the y-axis. R is some arbitrary length, and that would be r of x, and that length is x. The height is always perpendicular to your radius, so the height in this problem is going to be the curve, which is x minus x cubed minus 0. So the volume of our problem is going to be 2 pi integral r multiplied by h, and that's x minus x cubed dx. And what do we integrate from? We're told to go from 0 to 1. Make certain you have equal signs in there, otherwise this problem doesn't make sense. Figure out your answer. Either use your calculator or your mind, whichever works better for you today. All right, now for example 2, we are looking for the shell method again. Oh, this one's giving me directions. I am not going to tell you which method to use generally, but since we're practicing shell method today, that's why we have this in a direction. We have our curve, which is xy equals 4. So when x is 1, y is 4. When y is 1, x is going to be 4. And we have a nice little curve happening here. We also have the graph of x plus y equals 5. And when we put it all together, we're going to look for the area trapped between that region. Now, we are spinning on the x-axis. So once again, write the words. Let that help you. We're going to spin x. And if we're going to use the shell method, we must use y. Spin x, use y. I could do it the other way. And trust me, when you take a test, I'm going to give you a choice. However, for this one, we are going to look for the radius. The radius goes from the axis of revolution to some arbitrary point. Now look at that line. That has a height of y. So the radius with respect to y is y. The height must be perpendicular to what we're working with, and that's going to be a right minus left. So the height with respect to y is going to be the right curve, which will be 5 minus y, minus the left curve, which is 4 over y. So that tells us that the volume is equal to 2 pi r. So we've got our 2 pi integral. The r is y. The height is the quantity 5 minus y minus 4 over y. And that will have a dy. What are we going to integrate from? Well, I think we need to solve this equation. So if I take 5 minus y and I set it equal to 4 over y, I'm going to be able to solve this and end up with 5y minus y squared equals 4. Set it equal to 0. Y squared minus 5y plus 4 gives us the y values as 1 and 4. Then you use your calculator or your mind in order to solve this problem. All right, so let's sketch a graph and see what's happening here. So if we plot a few points, we're going to get a better graph. And let's see here. I think we're going to have a quadratic looking like this. We also know we have a boundary at x equals 1 and a boundary at y equals 1. So with this little region right here is what we're going to be spinning about. X equals 2. So when I use x equals 2, there we go. Draw where I'm spinning. Now, once again, the drawings are very important. Let's think about what's happening here. We are spinning parallel to the y-axis, but I really can't solve that equation. I have to use x's. That tells me I must use my shell formula. And the shell, remember, is 2 pi rh. I have to find the radius and I have to find the height. So let's look for the radius first. Now the radius is going to be drawn from where we are spinning to some arbitrary point in the middle here. There we go. Now I want you to think about that for a moment. That arbitrary point is a right minus left. So r of x is going to be the right number, which is 2 minus some arbitrary x value. Ooh, so there's the radius. That's a little different. The height is perpendicular to that point or to that line, and the height will be the curve that we're playing with, which is our x squared plus x plus 1 minus that bottom number, which happens to be a 1. So the volume is equal to 2 pi r. The r is the quantity 2 minus x times the height, which is your x squared plus x, and then we have a nice little dx here. Now, of course, we need our endpoints. Those are the x values. You can see from the graph that we're going to go from 0 to 1. After that, solve for the answer and you are done. Make certain you are practicing with your calculators. For example 4. All right, so now we want to determine the volume. Once again, we have x squared plus 1. So when you substitute in, you're going to get a nice little parabolic curve again for your x squared plus 1. Y equals 0.25. Well, that's a bit strange, but okay. Y equals 0.25. There we go. And x equals 0.5. That's what we have. And the last one, x is 0.75. All right, so that is getting a little bit close for what we're doing. And you can see that the region is this little region right there. And where are we going to revolve? We're going to rotate about x equals -1. So if x equals -1, that puts us over here. Excellent. Now, the radius. Let's go and look for that. First of all, did you recognize that we are spinning parallel to the y-axis? And that means that we're going to use our x values to get 2 pi r h. The radius is going to be equal to x minus -1, and x minus -1, of course, is x plus 1. The height is perpendicular to our radius. That height, though it's hard to see, is going to be our x squared plus 1 minus 0.25. That's very strange. All right, so then the volume is going to be equal to, now we're using x's, 2 pi integral from 0.5 to 0.75 times the radius, which is x plus 1, multiplied by your height, which is x squared plus 0.75 dx. Use calculator one more time and figure out what your actual answer is. All right, so for today's lesson practice, let's go take a look at it. For today's practice, I have a series of, looks like 7 problems. Spend no more than 30 minutes on these 7 problems and then complete the follow-up, which should be the odd questions. All right, that's it. We are now practicing the shell method, and next class we will mix them together. All right, you have a fabulous day.